So, how do you read a story that's 300 million years old? I mean, a story filled with lost worlds, massive extinctions, and the rise of absolute giants. Well, it turns out you don't need a time machine. You just need to know how to read the rocks. And the book for this story is written right here in the incredible coastal cliffs of Sidmouth over in East Devon. Now, this isn't just some pretty coastline. It's a globally recognized World Heritage Site. It's a remarkable window into our planet's really, really deep past. Okay, so let's open up the first chapter. We're going to start with the oldest rocks here, which take us way, way back to the Permian period. And this was a time of huge global change, long before the first dinosaurs even showed up. Back in the Permian, Earth was, well, it was a totally different world. All the continents were kind of smushed together into one supercontinent, Pangaea, and this created these unimaginably vast, dry deserts in the middle. Roaming this landscape were these amazing creatures, like the famous sailback Dimetrodon. But this era didn't just fade away. It ended in total catastrophe. So how do we know this stuff? Well, the evidence is literally written in stone, in rocks like this one, called breccia. See, instead of smooth, rounded pebbles you'd get from a long river journey, it's made of these sharp, angular chunks, all cemented together. And that tells geologists that the rock was broken up violently and then buried really quickly, probably by a powerful flash flood that tore through a dry, rocky landscape. And that catastrophe I mentioned at the end of the Permian, it's known as the Great Dying. And just look at this number. It is staggering. It wiped out an estimated 96% of all marine life and 70% of life on land. It is, by a huge margin, the most severe extinction event our planet has ever known. It just completely reset the course of evolution. But life finds a way, right? So after the Great Dying, we move into the next geological chapter, the Triassic period. And this is a story of recovery, as totally new forms of life started to pop up and populate a world that was still incredibly hot and dry. And what's so cool is that you can see this past perfectly in Sidmouth today. The town's famous red cliffs, they're made of something called otter sandstone. And that's a direct legacy of those Triassic deserts. It tells a story of huge shifting dunes and temporary salty lakes. So how do we actually read that story? Well, geologists are like detectives. They find clues everywhere in that sandstone. They find wind-blown sand, that's called aeolian deposits from ancient dunes. They find sediments that were laid down by temporary rivers. They even find minerals like gypsum and rock salt, which are called evaporites, and those are left behind when salty lakes just evaporated in the intense heat. Even the angled layers in the rock, called cross-bedding, can show us which way the ancient wind or water was moving. It's amazing. And in this recovering world, life started to get creative. You had these tough plant eaters, the therapsids, like Lystrosaurus, which did really well. But a whole new group was on the rise, the archosaurs. Now, this is a super important group. It gives us the ancestors of crocodiles, the very first flying reptiles, the pterosaurs, and, showing up late in the Triassic, the very first dinosaurs. And that, of course, sets the stage for the era that, let's be honest, everybody knows and loves. We are now diving into the heart of the age of reptiles, the Jurassic and the Cretaceous periods. The world is about to change in a huge way, from a harsh desert to a world of dinosaurs, teeming seas, and microscopic life that would build mountains. The transformation was just incredible. That old supercontinent Pangaea, it started to break apart. And as the new continents drifted, warm, shallow seas began to flood the land. The climate got way more humid, and those enormous deserts, they gave way to lush green forests. It was a complete environmental makeover. And back in Sidmouth, you can see this change recorded perfectly. The land actually sank, and a shallow sea moved in. So instead of desert sand being deposited, you get fine mud and silt settling on the seafloor. This forms what we now call the Sidmouth Mudstone. And the really crucial part is that this mud trapped and preserved the remains of creatures living in that sea, like the iconic coiled shells of ammonites. And with this new, lush world came the true reign of the dinosaurs. The Jurassic gave us those colossal, long-necked sauropods. The Cretaceous brought us the apex predators like T-Rex, and the oceans were ruled by these terrifying reptiles like mosasaurs. But at the same time, a quieter revolution was happening on land, the rise of flowering plants, which completely reshaped ecosystems forever. So on top of the mudstone lies one of the most remarkable rocks of all, chalk. It's the same stuff that makes the White Cliffs of Dover so famous, and it caps the hills around Sidmouth. And what's it made of? This is the wild part. It's almost entirely made of the tiny skeletons of trillions and trillions and trillions of microscopic, single-celled algae that built up on the seafloor over millions of years. The scale is it's truly mind-boggling. But this era also ended in fire and darkness. 66 million years ago, the Chicxulub asteroid slammed into the Earth. The impact triggered widespread wildfires, enormous tsunamis, and an impact winter that collapsed food chains. This one event wiped out all the non-bird dinosaurs and about 75% of all species, bringing the Cretaceous period to a dramatic close. Okay, so after that 300 million year journey through deserts and seas and dinosaurs, let's bring it all back to the present day. Because this story of deep time, it's not just ancient history. It's the architect of the very landscape we can walk on and see today. This is where it all clicks into place. We can see the town of Sidmouth here, with its river, its hills, its coastline, but the geology, it reveals this hidden truth. The shape of every single one of those features is determined by the invisible rock layers right underneath them, the exact same layers we've just been exploring. And the connection is so direct. The youngest and hardest rock layer, the Upper Greensand, it resists erosion, so it forms the flat tops of the highest hills. The softer Sidmouth Mudstone right below it erodes more easily, and that creates the steeper slopes. And that tough, old Otter Sandstone from the Triassic, that forms the strong vertical red cliffs right at the coast. You are literally looking at the geology stacked up in the shape of the land. So why does all this deep history actually matter? Well, it's incredibly practical. The town of Sidmouth was literally built from these rocks. They used the mudstone for bricks and the greensand for cathedral stone. If you're a fossil hunter, knowing the layers tells you exactly where to look. The pebbles on the beach are actually a vital sea defense. And that greensand up on the hills, it acts as a natural reservoir, an aquifer, that holds the area's fresh water supply. So you see, the story of Sidmouth is this amazing local story that has truly global significance. And it's written right there in the rocks for anyone to go and see. And it leaves us with one last thought. The ground beneath your own feet, right now, wherever you are, has its own equally deep and fascinating story etched into the rock, just waiting to be read. So what geological secrets are hidden where you live?